cheap solar power, batteries, and electric vehicles are changing the transport and energy sector as we know. I bring in guests to this podcast who will help you with their ideas to navigate this energy transition. By the way, this episode is also available as a video on our YouTube channel. Just search Energypreneurs. Thank you for joining. Good morning, Laura from Manila.
Good morning, Sahil from Canberra.
Wow. How is Canberra? Is it still cold? It's not, right? September is nice.
Oh, it's the kind of season I think I call onion season because you have to dress a bit like an onion. I think it was 2 degrees last night. It's like about 20 degrees in the middle of the day. So you're going to be able to take layers off today to keep it the right temperature. So, yes, very much like an onion, layers.
Yeah, but this is the time when the tulips are coming out, right?
Yeah, I think Florian's on at the moment. I normally live in Hobart, so I'm visiting Canberra at the moment. And I need to drop in on Florian and see the flowers this year. I went a couple of years ago and creativity of those flowers is amazing.
Now, the tulips get out of a nice storage. And you are a storage expert, right? Maybe you can explain a bit more who you are, what you have been doing.
Yeah, so I'm Laura Jones. I have a couple of different roles. They lead to an interesting intersection of different kinds of things that I do. I'm an electrical engineer in my background, and I'm both a researcher who does a mixture of engineering and social science. So talking about technology and then talking to people about technology as well. And I'm also a co-founder and director of a small non-profit called Circularity Alliance that aims at improving circular economy for PV in Australia. And I guess, in fact, one of our recent crowning achievements has been creation of a certification scheme for solar farms for circular economy. There's some early discussions toward applying a similar sort of approach for storage developments as well as solar developments. I do a few different things, and it's nice to have a few different kinds of experience, right? Because it brings a lovely diversity to things.
I'm just curious about certification scheme, which means the new solar plant has to get certified, or everybody has to get a certification saying eventually, that's your dream, that yes, I have a plan as to when I will get rid of how we will.
Yeah, so CPVA Certified, which is what we call the scheme, it started from a couple of different angles. Like one of them was, as a small non-profit and the startup non-profit, what can we do that moves the needle for circularity for solar farms in Australia? So we obviously spent quite a lot of time talking to solar developers, trying to understand what they think about circular economy at the moment. We found that in a lot of cases, they knew circular economy was a thing that they should think about, but they weren't sure how. CPVA Certified is like a structured process to think about the end at the start. So think about the entire life cycle of your solar farm from the start. So it has 4 key elements. You look at the planning. When you build a solar farm, there are opportunities to increase the circularity of the input materials to the solar farm. For example, recycled aggregate in concrete is a good practical example of how you can integrate circular economy products into your solar farm. And the idea is that if you're part of the circular economy, you also need to be a customer as well as a supplier. You look at operations. How does circular economy influence the operations of a solar farm? An example of this is we're doing a project at the moment with PV Lab, which is Australia's only PV test lab in Australia. So you can send your solar panels off to PV Lab, but they can measure the power output of the solar panel, look at electroluminescence images for quality and stuff like that. And it's a backsheet repair project. So where backsheet's this plastic sheet that's on the back of a monofacial solar panel. And the failure mode for those is that they get a crack in them, and then you'll end up with a solar array that turns off every time it rains because the water creates an earth fault. So this project was to repair that sheet with the material that you can buy. And this is an example of repair that you can do in practice if you're a solar farm with monofacial panels. Not all of them are monofacial. That's an example of circular economy in your practices. And then, of course, there's the bit that a lot of people think about, which is end of life. Everything you install one day is removed from service. One of the things that brought circular PV lines together at the start was that when we think of circular economy, we often focus on recycling. Recycling is great, but it's what you do with something that's broken. And a lot of the time, from what we've seen and from what we've seen in practice, many solar panels that are removed from service and sent to recyclers still work. Reuse is one of the main things that brought us together. As part of CPVA Certified, it's about trying to ensure that waste hierarchy is done in the appropriate way. If a thing works, we ensure that it's used somewhere. If it's broken and can be repaired, we repair it and then reuse it. If none of those things work, if something's broken and repairable, we then de-recycle it. So we built CPVA Certified as a way of being something that solar developers could share and show the world that have been considering circular economy and integrating circular economy into the core of their plans and practices and the like. It was something that developers could do this, that we could demonstrate that circular economy was a thing that you could think about, and over time increase the extent to which circular economy is built into solar farms. And as a small non-profit, it was something that was achievable to us. We could make a certification scheme. We could start small. So we've got one solar farm certified at the moment. We've got another one kind of in progress. We can start small and build up from there. It would be great if we get to the point that every solar farm does this. We know it's a bit of a journey. It is an extra piece of work that developers don't have to do. The benefits of it are it helps with community engagement. Find that communities in solar farm areas, they don't want to have an end-of-life solar farm that has a whole bunch of solar panels that no one's going to do anything with. And planning and development approvals, risk for financiers is probably the main value propositions for it.
Oh, wow. Is it very unique in Australia only, or it has been done in other places as well already? Must be, no?
Yeah, so we're the only of this type of certification scheme that we know of. There may be others. A lot of things happen around the world, but a lot of the time when people look at schemes like this, they're looking at things like extended producer responsibility schemes, which are a big piece of the puzzle. So, yeah, an extended producer responsibility scheme responsibilizes the manufacturer or importer to manage the end of life of products that they bring in. And they have a big place. We should absolutely have extended producer responsibility schemes, but one, you need to be a government to make one of those, and we're not a government, so we can't make one. And two, they focus on the beginning and the end, or particularly the end of life. What CPVA Certified does is it lets us focus on the whole life cycle rather than just the end bit of it. Yeah, it was a little bit, from what we could see, unique.
Wow, excellent. And people can find a little bit more about these things. You must have a website.
Yes, circularpv.com.au. You can see the results from our first certification on that website in more detail. So if you're a solar developer, please have a look at that website. Certify your solar farms. We would love to speak to you. We're also a member-based organisation, so we've got a couple of solar developers as members.
So if some of my listeners from a different part of the world, somewhere in Asia or somewhere else, wants to partner and do something similar with their local communities, I'm sure you will be able to help them or point them in the right direction.
Yeah, the principles are not necessarily Australia specific. The basic principles are circular inputs, circular outputs, circular operations, looking at plans, policies and procedures. So that's not necessarily Australia specific. There'll be locational issues or factors to consider. To what extent are there people who can manage end-of-life solar panels in your area? But the process itself is not necessarily specific to Australia.
Excellent. Yep. So I get that the answer is yes. If somebody wants to do it here, you'd be happy to help.
We are always happy to talk.
Yeah. Because simple things are difficult to do. No, when you have done it,
Yeah.
and you think, "Oh, wow, okay, this is no rocket science. Anybody can do it." But those are the things never get done, in my view.
It's interesting. So I do both, like Circularity Alliance as a startup, right? So like any startup, we don't have a lot of resources. We do what we can within the resources that we have. But my other half is as a researcher. There's a bit of tension there. While as a researcher, you're trying to understand a lot of things. You're trying to understand things in a lot of detail. But when you're doing things for startup, you're looking in a more pragmatic sense of things. What is it that is within our power to do? And I guess when it comes to building CPVA certified, it's in a bit of both of those things. It's what is it that's pragmatic that we can ask people to do, but what is it that's also backed by evidence?
Yeah, and what leverage you got.
Yeah, because it's a certification scheme where no one has a certification at the start. So there's that much value in a certification that no one has. But now we're getting more of them, so that's a good sign.
Wonderful. Congratulations on that. These things are very hard to put together and
Yeah.
pull it off.
Yeah. But it's a good journey. It started as one page and it now is a lot more than that.
If you have certified one and one underway, excellent.
Yeah.
Now, coming back to your other part of your life, you mentioned where you really want to dig down to the
Yeah.
details. Can you take us a bit more on that part?
Yeah. So I guess my background is an electrical engineer, but today I do a lot of social science work as well. Essentially, we do a number of things, but some of them is we get involved in new technologies being considered, being rolled out, and then we will help understand and build a big picture of the landscape around those technologies. For example, we might have a trial of a new type of battery management approach. For example, a virtual power plant is a common thing that we talk about for batteries. We might go and speak to the participants and understand what their perspectives on being in a virtual power plant is, and then relate it to what it is that the particular thing that's being built and tested are. A good example of this is we often find when people are considering things like virtual power plants, they'll make fairly simple assumptions around what it is that households would really like. So they'll say, for example, as long as we'll pay people enough money, they're generally going to be happy for the virtual power plant operator to do what they like with their battery, as long as they're getting paid.
Now, I have a question here. Because Australia is so much advanced from rest of the world, and you are so much advanced within Australia. What is a virtual power plant for an average person?
All right. Yeah, good question. So the way that we tend to operate an electricity system is we go and build big generators, hundreds or thousands of megawatts, and they provide a nice, really big block that you can operate. You can change the power or change what it's doing. What we have in Australia is a lot of what we would call distributed energy resources. So people with small pieces of equipment in their house, a couple of kilowatts of solar, or my Tesla Powerwall 2 has like about 13 kilowatt hours, 5 kilowatts of power. So we're talking like 3 orders of magnitude smaller than a large power plant. So when we want small resources to act like a large resource, what we do is we aggregate them all together and then tell them to act a little bit more like a large-scale power plant. And we'll often call them a virtual power plant. So you might have a company who will sign on a few hundred or a few thousand batteries and then have those devices acting electricity markets as if they were a larger generator. Sometimes they'll also provide different kinds of services as well. So not every part of the world has a market. In that case, those virtual power plants might be sold to whoever the central buyer is in your market and acted again like a large-scale plant distributed across thousands of locations rather than one. One of the differences between a virtual power plant and a large-scale power plant is if you're building a large-scale power plant, you're a large professional investor, like running large power plants is your job. manufacturers know how they work. You're building this power plant purely so that you can sell its energy to someone. If you're a householder, you haven't normally bought your battery so that it can provide services to the energy market. We find in Australia, most people buy batteries so they can be more independent from the grid. And this is in a bit of tension with the idea that you might be selling services from this battery to the market, because that's not why you bought the battery in the first place. So what I mean by people who operate virtual power plants making simple assumptions is they say maybe people who own home batteries are like these institutional investors that build big power plants, and as long as they're making money, they're happy. But we find in most cases that's not exactly what it's like. Householders are not large-scale investors, and they haven't been buying this for the same reason that a large-scale investor might buy a generator.
Yeah, but then if batteries still serve their own need of providing their security, and just by providing an insurance to the community, they get paid extra, I don't know, 5%, 10%, then it's a very interesting product. Then community, correct me if I'm wrong, all these distributed home batteries, cars, power walls or whatever, becomes a power station, and suddenly a big power station trips for some reason. So you don't need another one as a safety backup. You can tell everybody saying, hey, I want a bit from you, a bit from that. And that's what virtual power plant is, right? You are orchestrating them through a app, through cloud access or some people without knowing get paid in a way, no?
Yeah, it is like that. And there's a couple of threads in what you said there that are actually really important, because if you're saying your battery is acting in the market, the question always is, how does that work? And how does that relate to what it is that I want to do? For example, the question is, maybe your battery does what you'd like it to do, keep you independent from the grid in every situation except for emergencies. That's one type of virtual power plant controller you might have. And that might be the kind of one, which is exactly what you said. People don't really realize that it's happening, because 99% of their time, the battery's doing what they expect it to do. On the other end of the spectrum, you make this battery like a large-scale battery would, in which case it's being used really dynamically. It's charging and discharging all of the time. The way that it's doing that doesn't necessarily correlate to how the person in their house is using electricity. I've got these two projects in mind often when I'm talking about these things. I'm not going to name them, but there was one project where they did this second model I talked about. They had batteries in people's houses, and they put these batteries in the market as if they were a large-scale generator. And then we went and spoke to all of the participants, and they were a bit upset because they said, when we have a battery in our house, we understand how this battery is going to operate. So, for example, we have solar on the roof, and in the morning it will tend to charge until it's full. And then in the afternoon, I know that's a really good time to do things in my house that use lots of energy. When they were in the virtual power plant, that didn't happen anymore. They were charging and discharging at all hours of the day. And there were two impacts from that. One of them was, when am I supposed to do things in my house that use lots of electricity now? Because my battery isn't doing anything predictable anymore. And two, they were seeing things like a battery charging at 1 a.m. and saying, I bought this battery because I wanted to reduce emissions. What kind of energy is going into this battery? It's not solar. Is it green? So we found that the people got a little bit upset because the battery, A, it was unpredictable. We always say the way people live their life kind of wraps around the technology in their house. And two, it was in tension with their values. So their values were reducing emissions. And this battery didn't seem to be doing that from what they could tell. And it might have actually been doing that. It might have been a really windy time and it was wind energy going into that. But they didn't have the information to work with. There's nothing that told them why their battery was charging. They just knew that it was. There was another project that I was involved in that had a very different approach. It essentially built into the algorithm that self-consumption was the most important thing, which meant that we spoke to the people and they were like, I haven't really noticed, to be honest. It's all good from my point of view. So they were relaxed and happy about their participation. But it had the grid side impact was that it reduced the amount of virtual power plant value you get from those batteries by 90%, because people were self-consuming most of the time. But when they were self-consuming, you can't ask them to do anything else. Otherwise, they're not self-consuming anymore. So I think really it sits somewhere in the middle of that. Maybe virtual power plants are really useful when things get pretty hairy in the grid. That maybe day to day, a lot of people would probably prefer their battery does what they would like it to do, which is be a bit independent.
Yeah, these are new concept, new label, but again, also not very new concept. Like when I'm in Manila, I stay in a place called Rockwell, is a residential complex, which has a power plant mall, supermarket, but used to be really a power plant, coal plant many years ago.
Yeah.
And what these buildings do, even in case there is a power failure, they maintain a separate circuit where your essential lights are on. So basically, like running a power station, you know that it's going to be a very expensive power. So asking people to switch off, but people will not listen. So they basically said, okay, we have decided and pre-agreed what are the lights you want when we can afford the least, because they're running diesel. Just those power comes on, people know, okay, you are not supposed to run your aircon or maybe in one room. So this is a virtual power plant, means the one that we have switched off.
That's really important. Like one of the things, particularly if you're in a part of the grid where reliability isn't very good, batteries can provide backup. I did a project a few years ago on a tourist island in Tasmania called Birdie Island. This, like most rural networks, the reliability on the island wasn't great. So the people on the island had a lot of outages. This was a home battery trial. So we were helping people on the island buy batteries so that we could connect them together in a virtual power plant to resolve the cable that supplied the island got overloaded sometimes, about 20 days a year. We had a lot of interesting discussions with the participants, potential future participants, about backup because their reliability was pretty bad. And at the time we said to people, if you'd like backup with your system, you can have it. You can decide what parts of your house you supply, and different people made different decisions about what in their house was most important for them to supply. So fridges and freezers were common things because on Birdie Island, people often have large freezers because you've got to take a ferry to get to the nearest major supermarket. So you don't go that often. And there's a lot of local grown produce on the island, so being able to freeze that's useful. Internet is another common thing. So if there's a bushfire, you want to know where the fire is. So being able to access the internet still is quite important. And everyone on the island had a team. So of course they had a pump to supply the house. But pumps are actually quite hard to supply off of backup systems because they need lots of current to start. So some people did and some people didn't. What was interesting was they got their battery systems, they got their backup systems. And they had a controller that sat on the battery, and that controller optimized the battery. So essentially it had a target, which was to make the person as much money as possible with their battery. And it would charge and discharge the battery to meet that goal. But backup wasn't one of the things that it took into account, which meant we had a couple of participants who backup was actually the main reason why they bought this system. And then their optimizer was like, why would I put more energy in the battery than you're about to use? So the battery was nearly empty most of the time. So technically it would provide backup, but in practice, it wasn't something that the controller emphasized in its operation. I guess there's a bit of a meta reflection on that too. When you buy something and put it in your house like a battery, the more things you ask it to do, the less good it is at any one of those things. I guess you have to understand what you're trying to do with it when you buy it. And maybe an optimizer wasn't the right thing for those people who really cared about backup to have, because an empty battery doesn't provide you any backup.
Yep. That's actually a very good point, because it's like a driving an electric car. If you always looking at how much charge is left, it's very difficult for you to drive with a single digit charge left because you just, oh my God. I have I've driven a Tesla to 1%, quite a number of
Right.
times actually. And it was
Yeah.
in rural New South Wales, so we didn't have much option. We were running for an appointment. I said, okay, should be fine, should be fine. And then when I go to the chart, someone said, you know what? Even after into zero, it will give you 20 kilometers. That gentleman was very calm, but we were not when you're running. I know people
Yeah.
who hit the panic button when they reach 20%, saying, will I run out? Will I run out? So I can relate to these people who has taken a battery in the home just to have a backup. And he said, nah, it's enough there. They just be saying, no, I didn't buy it for that. No.
Yeah. I was reflecting, I think 17% is the lowest I've ever run my electric car. And that was feeling a little bit anxiety building for me. So I'm definitely in the don't run it too low crowd. Yeah. Actually, there's another interesting reflection that's related to that too. But this optimizer would learn people's consumption. There were people, what you were saying, where anxiety was related to state of charge. So the lower the battery was, the more anxious they'd get. And what would happen is these people were on a time of use electricity tariff. So electricity was more expensive at certain times of day.
Mhm.
So what it would do is it would learn their consumption and say, oh, use about 30% of the battery during peak periods. So it would aim to start the peak at 30% state of charge, which means it gets to the end of the peak pretty close to zero. And the household will look at this, be sitting on like 10%. And go, oh, I'm a bit nervous about this. So they'd reduce their consumption because they were worried that the battery would go flat. So they might use 25%. And then the next day, the optimizer goes, oh, turns out you use 25% for 25% of the battery. And then eventually they're shivering in the dark during peak periods. But the optimizer who's learned they don't consume anything. So there's a bit of sense making about living with an optimizer in your house. And one of the other things that I do a bit of work on is vehicle to grid. So vehicle to grid is this idea that your car battery might also be your house battery. So the charger that charges your car at home can also discharge it. And as you were saying, EV drivers sometimes have a bit of anxiety about the battery getting too low in their vehicle. And when you're saying you might plug your car into charge and it might actually discharge, this is a barrier for people to go over. We did a project with a fleet vehicle to grid rollout. It was called REVS, Realising Electric Vehicle to Grid Services. And it was a fleet project, just the fleet where these vehicles were going into. They were quite concerned about the impact of vehicle to grid on their ability to drive the vehicle. So what we did was we did a frequency control service with these vehicles. So in Australia, we have a 50 hertz power system, which means the voltage waveform switches between positive and negative 100 times a second, so 2 times 50. When you have, it's like a car, right? The car's driving along at 50 hertz. And if, for example, a generator loses, like we lose a generator due to a fault, it'll slow down like a car driving up a hill. You need to press the accelerator a bit more to keep the speed close to 50 hertz, vice versa. So if you lose some load, it'll speed up. You need to back off the accelerator a little bit. So these vehicles would charge or discharge to counteract any frequency disturbances that happened in the grid. So when the frequency goes down, it would discharge. And we picked this service because it only ever did after faults, which there isn't very many of them here, and it would take 5 minutes, which was 2% of the battery capacity. At the time, those services were worth lots of money. Now they're not worth very much because batteries, large-scale batteries, are all really good at this service. But that was the key thing for the fleets of, I bought these vehicles to drive and I'm concerned, it doesn't matter what data you provide evidence, I'm concerned that I can't use these vehicles to drive anymore with this vehicle to grid. So I'm not going to do it. So there is always a little bit of sense making that people have to do with new technologies to understand how it might interact with their life and their purpose.
True. But again, if you look at the numbers, I actually did a post on LinkedIn recently because there's so much competition going on in the electric car market. So the batteries that come in those cars are really cheap relative to if you buy the same kilowatt hour as a home battery, you pay almost 3 times, 4 times more. So the other way looking at it, as Dave Smith put it in one of our discussions, saying, you know what? You buy an electric car, you get a home battery for free. Because that way, I think it works better.
Yeah, you're right. Essentially, a car battery is dramatically larger than a normal house battery. Per dollars per kilowatt hour, they're about as cheap as you can get. It's interesting. So, as part of the project I just mentioned, we also did some social science research. So, we went and spoke to people about vehicle to grid. But we found often when you say, hey, vehicle to grid, and tell them a bit about what it is, they get really excited, but then talk about vehicle to home. So, it's the same battery. You say, that sounds amazing. I can be independent from the grid with my electric vehicle. There's a few more values tied up in it than for a home battery too, because for a home battery, you buy it just to manage energy, but for a vehicle, you buy it to drive as well. So it'll be interesting. I suspect that we're going to see a lot of vehicles bi-directional charging, but I suspect that a lot of it will be used for home energy management purposes rather than selling it off to the grid. That being said, I know Origin in Australia has just announced a vehicle to grid product. So essentially you get a charger, a vehicle that works with it, and recharging for, I think it's $400 or something like that. Can't remember the exact price. Baked into that would be the idea that they can use those vehicles in a virtual power plant kind of environment. So maybe I'll be wrong. We'll see how it goes.
They are also exactly the dilemmas and the challenges you are seeing when people signing up for virtual power plants, saying, bought it for this purpose, which is driving, and if I can't drive, hey, what's up?
Yeah.
But then you can also argue that even on your gasoline car, petrol is always not full. You topped it up last week by Friday or topped it up on a Friday. At certain times, it is half full, 10% full. It's always the case. And you are not always going for a long fishing trip, right? You might be just going to the supermarket, 5K out, right? So if people, and I'm sure that you can easily do, you can put a ceiling on your 60 kilowatt hour battery saying, okay, draw maximum 10 kilowatt hour at any given time. And if that will reduce the cost of ownership by 30% or 20%, of course, people will be listening because I saw some numbers. Signing up for VTT longer term, it could be 30% cost of your ownership if it's your second car, something like that, which is extraordinary.
Yeah. I think in some ways when we say we buy a vehicle for not for energy purposes, you could see this as an advantage in this concept too, because you think of your vehicle, you think of like kilometers of range, and you compare that to what you might drive in a given day. A modern vehicle, electric vehicle, 400 kilometers of range is not that abnormal for an electric vehicle that you buy. Most people, from the research I've seen, don't tend to plug their vehicle in every day. They tend to plug it in when it gets to the point where it needs a charge. Personally, I tend to plug mine in about 30% or so and then charge it. So with vehicle to grid, you're probably plugging your vehicle in every day because it's not providing any V to G value while it's not plugged in. So it may be that because we think of vehicles differently to how we think of batteries, that makes it easier for virtual power plants because you can say to someone, you're going to have 250 kilometers of range in your tank at all times with vehicle grid. And that's enough for pretty much everything that you could think of. And you can always press the charge button when you need more for long drives.
Yes, funny realities of life. This thing still called a phone, but uses this as a phone, right? Most people use it as a camera for document retrieval and voice over IP, which is really literally not phone, right? I know many people traveling globally do not have a SIM. They basically saying, no, this is, I use it when there is Wi-Fi and I use WhatsApp and these. I never call anybody. And This is basically the camera I carry. I don't know why it's still called a phone, no?
Yeah, it's definitely the case that over time, society and people are always reinventing ourselves. We think of things differently. Imagine if we teleported ourselves or teleported someone from 100 years ago to now and then showed them a phone. They'd say, wow, you've got all of the information on your fingertips. And then you'd say, yeah, I look at cat pictures. You know, I use it to look at memes. We've reinvented phones from what they were in the past to a device that was almost like our second brain sometimes. I reflect on that a bit with AI as well, where just like we are so used to being able to search anything, we don't have to keep as many definitions in our head as we used to because we've got our phones and we can search whenever we like. Maybe AI will mean we'll have different information in our heads in the future because we know that there are different ways of sourcing that information. It'll be interesting to see how that goes.
Yeah, absolutely. That's what I think for the electric vehicle. Uh, in many governments, transport department is responsible for electric vehicle because it has four wheels. But I think that's a really bad policy choice because electric vehicle is so much about energy and information, and eventually with AI connecting robots, it has nothing to do with transport. It's the phone has nothing to do with phone anymore, right? It is bigger than that. For every person you ask, it's more of their storage of photos and videos.
Yeah. It's funny, I did, as part of the work on the vehicle to grid project, I did some business models work. So I tried to understand what future business models might exist for vehicle to grid. And I'd do an interview and talk to the people about business models. And then at the end, you'd say, so tell me your crazy ideas. What do you think might be the future of vehicle to grid? And the number of people who said, oh, yeah, we'll have autonomous vehicle to grid vehicles being our distribution network in the future for energy.
Yes,
You'll have a storm and then a swarm of vehicles will drive up and plug themselves in and supply your town with electricity, or even private vehicle owners might have do that and use their vehicles as an energy transport medium like Uber for electricity. There's so many potential things that we could use a large battery on wheels for, and I guess it'd be fascinating to see which one of those end up being the things that we actually do.
Yeah, exactly. On your second example, there is no reason when average Australian consumes about, say, 20 kilowatt hour a day, average person in warmer part of Asia consumes 2 or 3 kilowatt hour a day. No reason when you're booking an Uber, why can't you book saying, I need 10 kilowatt hour delivered? A car comes in,
Yeah,
plug it in, you basically plug, take the energy out, go away. I don't want to own anything, no? This technology is there today, right? Right now it's available.
Yeah, and I know in some parts, in particularly around Asia, there are battery swap light vehicles like three-wheelers and motorcycles. There's nothing stopping you from grabbing a spare battery from the battery swap station and taking it home and plugging it in as well.
We are actually working on a project like that. So it's a battery swapping network on a wall, which right now is going into an electric three-wheelers. We said, why can't we put it along the river and it goes into an electric boat? And by the way, if there is an island on the other side, which is really relying on diesel, why can't you take two of them, one to ferry you to the other side and come back, and one is basically plonk your house in?
Yeah, because battery technology has improved to the point where you can put quite a lot of kilowatt hours into something you can physically lift, a number of kilowatt hours into something you can physically lift. It makes that, particularly for light vehicles, better because your car electric vehicle battery is quite heavy. Like they're hard to do swaps on because you can't pull it out and put it into something. For a light vehicle where you can physically move it like that, I think that works really well. And once you've got a battery, you can swap. What else can you use kilowatt hours in your head for?
You don't need to swap in a way. You can almost have a car dedicated to the battery. It's a battery on wheel. It comes in. And like old days, we used to get milk delivered.
I was thinking of milk.
Yeah, that thing can get out and go wherever needs to be charged. Another autonomous one can come in and plug it in. It could be 100 kilowatt hour battery as a service.
Yeah. can fit an awful lot of kilowatt hours like that. If you put the three-wheeler or something.
Yeah, you custom design one with, don't need to have a windscreen and driver's seats or anything else.
Yeah. Yeah. It's interesting, like the first internal combustion vehicles looked like a horse and carriage, but without the horse. The electric vehicles we have today look like an ICE vehicle, except without the ICE engine. Autonomous vehicles look like an ICE vehicle, but like they have this steering wheel that turns itself. In 20 years' time, autonomous vehicles will look quite different because we'll have different design points for it. Like you don't need a driver's seat anymore. And maybe if there are people in it at all, they'll sit quite differently to today. They don't need to see outside if they don't want to.
Yep. How excited are you with the autonomous vehicle space?
Yeah, it's been like, I think until we have autonomous vehicles driving around our roads, it's likely to be a while until we have that are ready for all use cases for like, the way we drive vehicles at the moment. But I think in a lot of cases, it's like trying to find the points or the places where these vehicles are really useful at the moment. So, for example, trains, there's a lot of autonomous trains out there because they're on tracks, right? In certain areas in cities, like, for example, you have your low emission zones in the center of cities. Maybe you'll have autonomous vehicle lanes where you only have autonomous low speed vehicles in there so you can make the roads narrower because they can all drive in an exactly predictable way because they can all talk to each other. So I think it's one of these things where you're going to see a little use building on a little use building on a little use building on a little use until one day we look out on the street and no one's driving a vehicle anymore. It's always taken by surprise.
Now, I got super excited. I think the gentleman name, was it
Mm.
John, who did a piece last week on Drive. He drove from Sydney to Melbourne, fully autonomous on the Tesla Model Y. He said, I don't like Teslas, but this is fun. And the whole 14-hour journey on Hume, which was quite fascinating.
And highways as well, because in highways you're left like you have people walking in front of you. People are there isn't many junctions.
No, but he
Things are-
did straight
yeah.
from Sydney
Mm.
car park office to Melbourne, all the way to Balti Bridge, extend, go there, South Melbourne. This is our office
Yeah,
without touching the steering.
that's pretty good.
I plan to do that in January. We are going from Sydney to Sunshine Coast. Let's.
Let's see how it goes. You see those videos sometimes of someone having a using the wheels.
That's
themselves driving
illegal.
the vehicle. Yes, it's illegal.
And the car,
Still happens though, right?
I think the car also, he was using a Model Y, Tesla, and
Yeah.
Model 3, and he gets this if he doesn't touch the steering, it gives you a vibration. If you don't, it will write you off because he was wearing a sunglass, so the camera could not see his eyes. So then he got Tesla, and Tesla said, and this was all in the documentation. He said, no, take your sunglasses off. Then the car can see that you are actually looking forward and your eyes are not closed. Then you don't bother you. I think, really, what's the whole 1 hour of it? Yeah, they said, wow.
I'm sure someone will work out a small machine they can build that fools the Tesla into thinking you're awake very quickly. Because humans are ingenious like that, right?
Yes, but police officers are also quite genius.
It's like, it'll be the next version of police pulling you over for being on your mobile phone while driving. It'll be sleeping while driving.
Yeah,
Like that. But they'll pull you over and then they'll have to wake you up and give you a fine.
yes, that's a good point. But it will provide a very different level of autonomous to a lot of people with disabilities and others because taxis are prohibitively expensive, especially for short distances. Even India is maybe providing you support again. That's expensive for the taxpayer. But if a machine can do it reliably, why not? No.
Yeah, and the other thing I find, because I have a disabled family member who uses wheelchair, and we also find that wheelchair taxis are also really unreliable. When you get to the evening, there just aren't any of them on the road anymore. So even if you have someone in a wheelchair that is get from A to B, and there's no one to pick them up. I think having vehicles that can do this that kind of don't sleep, I think is the other advantage of this as well as making it cheaper and more accessible. And there are a lot of opportunities from it. to hopefully make things better for people. I know we did some surveys recently on vehicle perspectives on electric vehicles, and a couple of the comments that we got were from people who were wheelchair. They're like, I don't think electric vehicles are for me at the moment because I think they're suitable for people in a wheelchair. So demonstrating that they can be better. Good.
Yeah, I'm sure as the market expands, there will be
Yeah.
special purpose vehicles or any vehicles can be made.
Even when they're not autonomous, building fast charge stations without curbs for at least a couple of the points so the people in a wheelchair. There are some US design standards for designing charging stations for people in wheelchairs that talk about how high the screen has to be, because obviously the screen's mounted for someone who can stand, can see it. Someone who's in a wheelchair can't. The connectors for cords, how heavy the cords are, how far away they can go, all that kind of stuff.
Eventually, what you see mostly in Asia, Philippines, Indonesia, like you walk into a gasoline station, there's always somebody there who is helping you. The labor is cheaper than the systems that needs to be in place. But so there is no reason why there can't be a robot doing that, because the robots are becoming so cheaper, no?
Yeah. Or wireless charging, because then you just drive somewhere and then it charges.
That I don't know. People will start talking about induction issues, magnetic interference.
Yeah. We have a magnetic interference device in our pocket.
Yeah.
Mobile phones come with the inductive charging quite a bit too.
Yeah. EMRs are a big thing, but the new guys always.
Well, yeah. I think whenever there's a new technology, there's always this, and we don't know yet. Like, we haven't got many inductive charging locations yet. And electric vehicles themselves are pretty new. So if there are these kinds of issues, we might not know it yet.
But that would be amazing. Inductive charging, you don't have to worry. Every base charging station charge whatever you want.
Yeah, from a access in a wheelchair point of view, you just being able to drive somewhere is far easier than having to wrestle with a cord, no matter how easy that cord is to wrestle with. I think the advice that I got from someone in designing a charger for someone in a wheelchair was go get a 10-year-old, put them in an office chair and tell them they can't get up and ask them to plug the vehicle in. They can do it. Someone in a wheelchair probably can. If they can't, you've probably got problems.
Yes, that's a good point. Thank you so much for your time. Is there anything else I could have asked?
I think it's been a wonderful discussion and I've really enjoyed it. So thank you so much for inviting me, Sahel. Yeah, I always enjoy talking about this kind of stuff. So thank you for the opportunity.
Thank you. And how can people reach you if they want to learn a bit more?
You can find me on LinkedIn. If you search for Laura Jones on LinkedIn and look for the Laura Jones, the A and U and circular PVA lines. I'm always open for a connection request. You can get to me at laura.jones@nu.edu.au if you'd like to email me, or you can have a laura.jones@circularpv.com.au to get to me too. Always happy for a chat.
Thank you so much, Laura. Thank you.
Thank you very much.
We hope you enjoyed this episode of Energypreneurs. If you enjoyed this, don't forget the full video is on YouTube. Just search Energypreneurs. Thank you. See you next time.